Alright you guys, this is GCO5 and this video deals with worksheet number 8. This particular area deals with a continuation, of course, of the last few. But in particular here we're looking at composite or composite transformations, depending on how you want to say that. But basically this just means more than one transformation. So it could be a rotation and a reflection and a reflection, a translation and a rotation. So we're going to look at now a sequence basically of these events. Now when you're doing a sequence, there's two important things to talk about. One is, does the order that you do them in matter? And the second thing is how do we notate or describe to someone which to do first and which to do second. So the first thing we're going to solve or talk about is, does order matter? So in this diagram we're going to do a rotation of 90 about the origin, and then we're going to translate it. Here we're going to translate it first and then do the rotation of 90. And we're going to see if we get the same values or same answers. Now to do a rotation, I like using my patty paper to do it quickly. I do now have a coordinate rule that could also help me to do this quickly, but for the sake of the visuals I like to do a rotation about the origin 90 degrees, just as simple as that. So 2 and -7, we got -6, -7, and then the last point is here at -8, 2. Alright, so now I just connect these quickly, and I have performed a rotation of positive 90 degrees. I'm now going to translate things 3 to the right and 5 down. And so in doing so, if we go 3 to the right, 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. This is our end result right here of our first composite or composite transformation. So this is the end result. This is our A prime, and this would be A double prime, the first thing that happened and then the second thing that happened. Let's go over here and now do the exact same things but in a different order. This says slide 3 right and 5 down, 1, 2, 3, 4, 5. So here is C prime, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5. So our first motion was a translation this time, and now we're going to do the rotation. So again, for sake of ease, I'm going to mark my points, mark my origin, and I already had those nicely from the previous one, and now I'm going to rotate it 90 degrees and see where it establishes itself. So it was here, it was here, and then the final point is at -3, -5 here, or +5. So we can already see, before me doing very much of the filling in here, that this location is not the same as this location. So what we gain here is that the order that you do them in matters greatly. Okay? So be careful about when they tell you to do this first, do it first. Okay? Now let's talk about notation. The way we notate things is, if we want to do something first in math, whether it be with composite functions, let me speak to that for a second. Sometimes, maybe previously, you've seen something that looks like this maybe. This is called a composite function, because what you do is you plug in 2 into the function g, and you get that answer, and then that answer gets placed in for the value of the function f. And so you work on the inside materials first and then to the outside. The same thing if you were given a question like this, you would actually do the inside first and then you would apply the outside. The same rule applies here when we're denoting the order to do things. Notice we're translating and we're reflecting triangle ABC. But the first thing that you will do is the one that is beside the original. We're going to first reflect triangle ABC. So first we would do that. And then secondly, we will translate it. Now most students, when they look at this notation, they say, oh, translate, then reflect. That's not correct. They are separated by this little point here. You'll see this again in a second. But the one on the inside takes place first, and then the one on the outside. So for instance, here in this question, you would do a rotation first, and then you would do a reflection second. So it's a little backwards for some of you, but it does. It's a consistent pattern in mathematics in terms of composite functions, or even the way we work with parentheses in the order of operations. So let's make sure that that's clear to you and show you how to write these. So if you were trying to describe a translation first, followed by a reflection over the x, the first thing would be written here. So we would translate -5 and 3 to the triangle. This would be first. And then the second thing we would do is a reflection over the x-axis. This would happen second. First, and then second. Here they want us to do a rotation of 73 degrees about O and then translate it. So first we would rotate 73 about O, and then second we would translate it by 11 and 9. It's written kind of in a reverse manner, but you'll get used to it. So let's take a look now at some specific composite or composite transformations. And in this case, we're going to do back-to-back reflections. So we're going to reflect over the x equals 1 line, this one, and then we're going to reflect over the x equals -4. So I'm going to again quickly jot these down. 1, 2, 3, 1, 2, 3, that would go there. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 would go here. And this would also go in the same location. 1, 2, 3, 4, 5, 6. 1, 2, 4, 5, 6. So our first reflection would place it here. And then our second one was over this line, so it would land here, and here, and here would be the final result. Now what we want you to look at here is kind of the overall pattern here. So notice this was our original, and then the first reflection reversed the orientation, and then the second one reversed it back. Notice the original to this one has a very powerful look to it. We see that this is a translation. Do you see that? How each point, C to C double prime, has moved this far, and so has B, moved the exact same amount, so has A. This is our definition of characteristics of our translation. Now let's also look at some other characteristics. The total distance traveled is 7, 8, 9, 10. So they went a total of 10. And we notice that the distance between the lines is 1, 2, 3, 4, 5. So we notice that if you reflect over parallel lines that are 5 apart, you will translate your shape 10. Why would that be? Why would the distance between your parallel lines, let's say distance D, why would this distance be if I took a point and I reflected it twice? Let's see if you can figure out why. The first reflection would land you wherever it does, so this distance would be the same as this. The second reflection, so this is A and A prime, the second one would land you here at this distance. Now notice what's taken place. This distance gets doubled because the first reflection doubles that amount and the second reflection doubles that amount. So the distance between the parallel lines will always be half of the total translation distance. Let's try a couple more quickly, going in a different direction a little bit here. So here we have our shape. It's positioned here in between the lines, but that doesn't matter. This says first to reflect over y equals 2. So that would place us right in this position right here. So A prime and B prime and C prime. So the first reflection goes here. Now the first reflection reverses the orientation, we're backwards. And then when we reflect a second time, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, we will get the points here, A double prime, B double prime, C double prime. On the second reflection over the parallel line, we gain again a very clear picture of a translation. We see the original and the translated figure. Now let's see if we can guess how far the translation is. From y equals 2 to y equals negative 2 is a total distance of 4. Now that should mean that the translated distance will be 8. Let's see if it is. Let's count from C to C prime. 1, 2, 3, 4, 5, 6, 7, 8. Every point, by double reflecting it over that set of lines, went down 8. Now remember, we said order mattered, and so they had us reflect over this one first, and then this one second, took us down 8. What happens if we reverse that order? So in other words, if we reflected on x equals negative 2 first, and then this one, what do we guess? That we would maybe go up 8. Let's see what happens. So the first reflection would place us in these positions. If we reflected first on y equals negative 2, would land us here. And then the second reflection would reverse back the orientation. So 1, 2, 3, 4, 1, 2, 3, 4. C prime would go here, and B prime would go here, and A prime would go, double prime, sorry, these are double primes, would go here, and we are in our final double reflected position. And sure enough, it is a translation again, and there's a distance of 4 here, and so we expect it to be a total of 8, which of course it is a distance of 8. But this time it's up. So how do we know? When does it go down 8? When does it go up 8? Well, just follow the order. Take a look. This said start on the y equals 2 line, that's the top one, and then reflect on the next one. That's a downward motion. This one said reflect on y equals negative 2 first, and then the y equals 2. That's an upward motion. One last thing. Let's just see if we understand it. It says, given these parallel lines, can you determine the resultant translation? So let me tell you how I figure this out. Y equals negative 2 is somewhere here, let's say. Y equals negative 5 is, say, somewhere, let me just expand this, is somewhere down here at y equals -5. So it says start at -2 and then reflect over -5. So first of all, that's a downward motion. Second of all, the distance is 3 from -2 to -5. So the overall picture would be to go down 6. Now how would I write that? That would be a translation, leaving x alone and taking the y values down 6. Let's do one more. Our two lines of reflection are x equals 1 and x equals -2. It tells me to do this one first and then this one second. So this tells me our motion will be left. The distance between these is 3. So our final result will be to go left 6. So if I was creating that translation, that would be left 6 and the other y value would stay the same. Direction is determined by the order they're done in. Distance is determined by double the length between the parallel lines.